Hello, my dear viewers. I want to thank you for tuning in. In this lecture, we are going to look at a number of chemical reactions that are very important in forming the basis for analysis of reactions and combustion in thermodynamics. If you want to analyze the products of combustion of a particular fuel, then you need to understand these kind of basic reactions. So to begin with, we shall define combustion. First of all, we said combustion refers to the chemical reaction that occurs between fuel and air to form combustion products with energy release. So we are beginning with the generic form of combustion equations, and we want to see carbon to carbon dioxide. If it has a complete combustion with oxygen, then to form carbon dioxide. So we have C, we are saying we have carbon plus oxygen giving you carbon dioxide. So this is a solid, this is a gas, and this is a gas. Now, analysis of this reaction by mass. So we know, first of all, that carbon the standard carbon is 12 kilograms by mass. Oxygen, this is atomic mass. Oxygen is 16 kilograms, and we shall be looking at sulfur, which is 32 kilogram, and so on and so forth. Nitrogen can be 14. So we shall be seeing at a number of them. Now by mass, that would mean you have 12 kilogram of carbon, solid carbon, plus, now this is a molecule of oxygen is composed of 32. So we shall have 32 kilograms of oxygen, of course, giving you, what is this? This is 12 plus 32. So 12 plus 32 gives you 44 kilograms. So it will give us 44 kilograms of carbon dioxide. What about if we are saying in a number of moles? So by number of moles, we see that here we have 1 mole of carbon plus 1 mole of oxygen, giving you 1 mole of carbon dioxide. So here, if we were to talk about maybe 1 kilogram of this fuel, if carbon was the fuel, then you would have something like this. You would divide all this over 12 over 12. So maybe let me put it here. Maybe you would have 1 kilogram of carbon plus 32 out of 12 kilogram of oxygen, giving you 44 out of 12 kilogram of carbon dioxide. So that is it. Now what about if we are looking at carbon If we are looking at carbon to carbon monoxide, that is incomplete combustion. Combustion of carbon. So that means I will have carbon plus oxygen. This would be carbon monoxide. This is a gas, this is a gas, and that is a solid. So how do we balance this equation? So to balance this equation, I will need to balance oxygen first of all by putting 2 here, which imbalances carbon, and it will prompt me to put 2 here. So what does that mean? If I change my pen, that means I'll have 2 times 12, that will be 24 kilograms of carbon. Okay. I will have carbon plus, now this is going to be 32 kilograms of oxygen, giving me, remember carbon is 12 and oxygen here is 16. So 12 plus 16, that would give you 28. 16 plus 12 is 28. 28 times 2, that is 56 kilograms of carbon monoxide. Then by volume, if we are talking about by volume, then we shall say not by volume but by moles. By number of moles, by moles, I will say 2 moles of carbon reacting with 1 mole of oxygen, giving you 2 moles of carbon monoxide. This is 2 moles. 2 moles of carbon monoxide. What about carbon monoxide to carbon dioxide? So I have carbon monoxide reacting with more oxygen to give carbon dioxide. This is a gas, this is a gas. So this would give you 12 plus 16, that is 28 kilograms, plus, of course, this is carbon monoxide, plus 32 kilogram of oxygen, giving you how much? Of course, you need first balance. This is not balanced. So what we do, we balance first. So this is carbon monoxide. Oxygen is not balanced. If I put 2 here, what would it be? It would make oxygen 4. So here, if it is 2, it would warrant me to put 2 here to make now carbon balanced, but it would affect oxygen. So oxygen now, this oxygen becomes what? If oxygen is 4 here, this side, it is 6. So if it is 6, what happens? I need to put a half here. So if I put a half here, this becomes 2, and this becomes 4. Oh, so this is balanced. So oxygen 2, it becomes 4. Carbon 2, carbon 2. So this is now balanced. Sorry about that. So now this was the reaction. Now that would give you, if this is 28, this is 56 kilograms of carbon monoxide plus 32 kilogram of oxygen, giving you this is 32 plus 12, giving you 44. 44 times 2, that is 88 kilograms of carbon dioxide. If we are talking about by volume, this would be 2 volumes, 1 volume of oxygen giving you 2 volumes of carbon monoxide. If it is by mole, then moles, this would be 2 moles of carbon monoxide plus 1 mole oxygen, giving you 2 moles carbon dioxide. These are very important to note. Then about sulfur dioxide, that would be sulfur plus oxygen, giving you sulfur dioxide. So sulfur is 32, so 32 kilograms sulfur plus 32 kilograms oxygen, giving you, this is 32 plus 32, that would give you 64 kilograms of sulfur dioxide gas. If we are talking about in terms of volume, this would be 1 volume of sulfur. No. Note. We can't measure this sulfur in terms of volumes, but we can take it up in terms of mass. So by mass, that is it. By moles, then it would be 1 mole sulfur plus 1 mole of oxygen gas, giving you 1 mole of sulfur dioxide gas. What about if we are talking about hydrogen to water? So hydrogen burns in the presence of oxygen to give you water molecule. So we need to balance this equation. You can put a 2 here to see what happens to hydrogen. This becomes 4. If I put the 2 here, hydrogen becomes balanced and oxygen is balanced. So what about the mass of hydrogen? Mass of hydrogen is equal to 2 kilograms. So because atomic mass of hydrogen is just 1 gram or 1 kilogram. So by mass, here I'll have 4 kilogram of hydrogen reacting with how many? This is 32 kilogram of oxygen, giving you, we have water as 16 itself. So 16 times 2 will, 18 is oxygen 6 plus hydrogen 2, becoming 18. So times 2 of 18 times 2 will get 36 kilograms of water. If we talk about it in terms of moles, then we have 2 moles reacting. This is 2 moles of hydrogen with 1 mole oxygen, giving you 2 moles of water. Since we have 2 gases this side and giving here, if this is vapor, then we shall say this is 2 volumes plus, this is 2 volumes of hydrogen plus 1 volume of oxygen, giving you 2 volumes of vapor. Okay. So, ladies and gentlemen, these are the generic combustion reactions of that we need to understand as we enter into reactions and reactions, of course, of combustion, and then analysis of the products of combustion. So failure to understand these basic reactions, then you will not be able to understand the bigger calculations that we shall be in. Thank you so much for following, and see you in the next lecture.